All right, video part 2, still on lesson 1.2.3, talking about perpendicular slopes and parallel slopes. In the first video, we saw that if you have slopes that are the same, those lines are going to be parallel. If you have slopes that are perpendicular, if you have lines that are perpendicular, those slopes are going to be opposite reciprocals, meaning they are flipped and one is negative. That's actually a great place to pick up because we're at C and it says talk about a pattern that works for these perpendicular lines or these perpendicular slopes. And I'm going to write it using letters because it would work with any number. And so I'm going to say if one slope, if one slope is, and I'll do this, A over B, then the second slope is going to be negative B over A. Okay, just meaning, again, just trying to show it using letters that if you have a slope and then a second slope that's perpendicular or a second line that's perpendicular, they just get flipped and one is negative. So this is a case where two lines are perpendicular. Then line 1 has a slope that, line 2 has a slope that is flipped or opposite reciprocals. Okay. So slopes of perpendicular lines, this is going to be the same kind of idea. It's just saying now how can using this drawing explain the slopes of perpendicular lines must always be negative B of A. And again, they're just saying A and B cannot be negative because if A or B was negative, we would have undefined because when you flip them, say you have A over B, if A is negative, that could still work. But as soon as you flip it, then you'd have negative B over A, and you can never have 0 in the denominator. Because 0 in the denominator, if you try to do it in a calculator, it's going to give you an error. Alright, so that's why they have to include that in there. But what that's saying is trying to use Sabrina's drawing to explain that. Well, you could write this all different ways. But you could see in line 1 that they give us, you have a positive A over B, and then when you flip that line, you rotate that line, your A is now becoming your run, and your B is now becoming your rise. And that is, like I said in the first video, if it's going left to right, that's negative, so it's going down and then positive to the right, and so that makes line 2 a negative B over A. Okay, now it says, what if the original line has a slope of 0? And so I'm going to explain it this way. So like I said, if you have slope, or line 1, slope of 0 could be written like this. It could be written as 0 divided by 1, because 0 divided by 1 is 0. Okay, now explains what happens if it's rotated 90 degrees. Well, that would create a perpendicular line, meaning we're going to get this pattern of flipping and making negative, which would give us line 2 being a negative 1 divided by 0, and that is what we call undefined, because you cannot divide by 0. Okay, having a slope of 0 means that you have a. Sorry, let me grab the lines here. If you have a slope of 0, that means that's a straight horizontal line. If you have an undefined slope, that means it's a vertical line. So the parallel aspect, the perpendicular aspect of it is still there. It's just that you get an undefined slope. Okay. Lastly, last problem, you have this point 5,7, and he wants to reflect it over this line. Negative 2/5 x plus 6, and he predicts that the new coordinate is going to be 2, 2. Without graphing, how can you confirm the answer? I'm not going to graph it, but I am going to bring you back to the first problem to see this. Okay, what's happening here, if I drew a line from R to R, and you can see it right here, it creates a perpendicular relationship between the line of reflection and the line that connects those 2 points. And that relationship exists with every reflection. It's the reason that the diagonal counting method works. And so that is what we're going to apply here, is that we would have to use the opposite reciprocal of this slope right here and that opposite reciprocal should bring us from this point to that point. And if it doesn't, then that point would not be a reflection, okay? Or that point would not be an accurate reflection of 5, 7. And so opposite reciprocal of this line would be flipping it and making it positive. And so the opposite reciprocal would then be 5, 2. If I move 5, 2, I would not get, edit that and pause for a second, but we're back. And so 5, 2 would be my opposite reciprocal, or my slope that I need to see. Well, let's look at what we would need to go. So if I wanted to go from 2 to 5, if I want to go from 2 to 5, that is a run of 3. And so run would be there, which means then I need to figure out the rise. So rise over run. I should use my slash marks. It makes more sense to me. It's like a fraction. So my rise over run, my run has got to be 3, because to go from 2 to 5, that's a run of 3. And then to go from 2 to 7, that is a rise of 5. And so what I see here is that I would need a slope. If these were truly reflected, I would need a slope of 5 over 2, but these points actually have a slope of 5 over 3. And so without graphing it, I can confirm that they did not reflect because they should have had that opposite reciprocal slope. Okay, make sure you do the learning log. There is no math notes. I'm sorry for the long video here in the second one. Again, this is a case where some of them that I went through kind of quick. My answers are pretty short. I want your answers to be longer. These are just my explanation with short answers. If you want further explanation, just email me and say, hey, problem 173, I'd like more explanation, and I will make it for you as soon as I can.